I would like to start with Alaska. Andrew Pavey, Pavement Management Engineer. So I let him present Alaska's presentation.
As he said, my name is Drew Pavey, and I'm the new Pavement Management Engineer for the state of Alaska. But as you can see, Alaska is a very large state, but even though it's large geographically, we don't actually have that large of a road system. The roads that are there in red, and our roads expand from western Alaska down across the Aleutian Chain to southeast in our coastal region. And our state is split into 3 different regions. The first of which is our northern region, which has extensive permafrost and also very large temperature differentials. It'll go from 90 degrees in the summer to -50 to negative 70 degrees in the winter. The second region is our central region, which is where Anchorage is. And that's our urban center with about half the state's population in Anchorage itself. And we have extreme studded tire wear in Anchorage. We'll rut up to an 1/8 inch a year on our main highway. Then our south coastal region is very temperate, and it has a lot of freeze-thaw. So total, we have about 7,600 centerline miles of road, but only about 4,300 of those are paved. And as I'm the pavement management engineer, I'll talk a little bit about that. We're currently working with Fugro to collect data on our 4,300 miles of road. We're collecting rut, roughness, and cracking data on that, and it's all their automated collection. And I'm currently implementing agile assets, which has been a bit of a process. It's taken us a good number of years now, but we're almost up and running with it. It'll be in December that it will hopefully actually be operational and I can start to use it. Still have a lot of work to do with it, a lot of optimization to do, and I'll be using those for our network-wide recommendations, and some of those will be the preservation treatments. So we're currently using a number of preservation treatments. A couple of them are our sand seals and rejuvenators, being our GSB 78 and 88 that we are primarily using. We're looking at a thin inlay, which will be about the first time we've done that besides M&O treatments next year. We're also doing a microsurfacing next year. It'll be the first time we have done that. We're just about to finally get the mix design finalized on, hopefully within the next week or 2. And then this summer, we actually put down 2 hot applied chip seals, double chips. So the first treatment to talk about is the thin inlay. It's our Type 4 Class A, which is a Marshall mix design. It'll be 1 inch in thickness. And as we are putting this in an urban area of Anchorage, we want to specify that the aggregate used is from a hard aggregate source. Rutting in that area is our primary distress. So we're specifying a Nordic abrasion value of 8 max. And we're using a very highly polymer modified binder for this, being a 64-40. And we're using that because we've seen with our prawl testing that as we lower that low end down from 28 to 34 to 40, we get better prawl results. I think it's because it prevents a glassy state from forming on the binder so it doesn't shatter from the stud impacts when it's really cold out. We're hoping for about a 5 to 7 year life out of that. There has been resistance to change. I think that's probably pretty common. And everybody just seems to like doing things the way we've always done it. They don't like change. It's perceived as a driveway mix, our thin mixes, as they've historically been used by our maintenance groups, and they just use whatever's on hand. They put it down maybe a 1/2 inch thick, and then it doesn't last very well. So I'm optimistic. This is a test strip on the project. It's not actually the whole thing we're doing this on. I want to do this, show that it does get adequate performance over a few years, then hopefully we can start using this more widely because we're consistently milling up a 1 inch rut and putting 2 inches of pavement back with our super pave or our type 2 pavements. So the next treatment is our microsurfacing. I'm really excited about this one. It's a very highly polymer modified emulsion. We were originally specifying that 64-40 binder for this as the base because of those prawl results we've seen. And we're changing it, or potentially changing it to a 64-34. This is probably one of the final steps on the mix design, is changing it to a 64-34 because of the set times we've been seeing in the lab formulations on the 64-40. And if we do make that change, we're going to be holding the residual asphalt to our multiple stress creep recovery requirements of our 58-34 binder. If we do go with the 64-40, it will be holding it to the multiple stress creep recovery requirements of the 64-40 binder. So we're using a type 2 ISSA. We're doing a scratch course and a surface course for this, and we're also tacking the roads first because they are a bit older. So for the mix design, we are using a lot of residual asphalt, 10 to 11% residual. And again, this is going back to the parallel testing we've done on both our hot mixes and some of the micro surfacing. And again, we have seen the more residual asphalt we have in this, the better prob results we get. And I think it might be because of the binder properties itself, where when it's cold out, it's absorbing the impacts and not shattering. When we used less residual, when we had less residual in our parallel testing, it blew the samples apart. It did not hold up at all. So we'll see how it goes. I'm pretty optimistic given the parallel testing, but you have to get it on the road to really see how it does, because lab doesn't always relate to field performance. So these are the samples after the parallel testing. If you don't know parallel, it's where we take a bunch of metal balls and just beat these samples with it near freezing temperatures as water's going over it for 15 minutes. And it's a very aggressive test. Like I said, the first micro samples we made blew apart, didn't even survive the 15 minutes. So we've gotten to this state, and the ones on top are that 58 minus 34. They had 16.4 cubic centimeters of loss over the 15-minute test. The ones on the bottom are the 64 minus 40, and they had 14.9 cubic centimeters of loss. To give a comparison, we did parallel testing on some super pave mixes using aggregate from a hard aggregate source, and those had about a value of 20, so they actually lost more pavement, more material with a super pave 5834 binder with hard aggregate. So it's pretty impressive to get these results back. The other treatment to talk about is the hot applied double chip seal. We are using pre-coated aggregate, and they're putting these on two different roads. One is in Anchorage, an urban area on Rabbit Creek, 4.2 centerline miles. The other one is our Parks Highway, 140 miles north of Anchorage. It's a lot lower traffic volumes. I think it's less than 2,000 ADT on that highway. And we're hoping for about 5 years of life out of this. We'll see. Rabbit Creek varies from 500 to 5,000 ADT per lane, so low volume to quite high volume. And we are pre-coating with neat oil, our 52 minus 28, and we're using slightly modified C&E chips. And the base binder that we're shooting, the binder is a 58 minus 34. It's a pretty highly polymer modified binder. So on Rabbit Creek, we are applying this for an increased friction. That road has a lot of steep grades and also a lot of curves on it. And we have tried high friction surface treatment for increased friction. And in Anchorage, in areas that didn't last 1 year, one winter, between plows and the aggressive set of tire wear, we could see bare pavement after one winter on our more highly trafficked roads in Anchorage where we put it down. So we're hoping for a bit better with the chip seal, and it's also a fifth, sixth, seventh of the price, so it's a lot cheaper. So this is a picture of the hot applied double chip. We feel like on Rabbit Creek it turned out pretty well, but so far it seems like mixed results on our Parks Highway. Part of that can come back to the contractor's familiarity with chip seals, because in our central region, we don't really use them. This is the first chip seal we've put down in probably about 13 years. It's been a long time. Our northern and south coastal regions use them a lot more, but Anchorage, we had a bad experience 15 years ago and hasn't been used since then. So really hoping this holds up okay. Another picture of it. And we did see a little bit of chip loss on Rabbit Creek after some heavy rains. Potentially it was overshot. We'll have to look into that more. But after those came off, it seems to be doing a bit better now. So for maintaining relevance of pavement preservation, for us right now, it's trying new treatments and evaluating them. We hadn't done a lot of preservation for a long time in central region. Northern does the chips. They do some high floats in permafrost areas after they leveled the road back out. And we just have to try them, evaluate their performance. I'm technically a part of research with pavement management, both asset management and research. So I'm going to be doing monitoring on the micro surfacing for the next 3 years post-construction, see how it does, see how it lasts, do site visits every year. We've had a unofficial request to do research on the chip seals, as one seems to be holding up better than the other. So we might be doing one to that to compare the two, dig into what happened differently in construction. It can also be challenging because a lot of people don't seem to like change. They like doing things that they've always been doing it, just keeping it comfortable. I think that we're getting past that and we're evaluating more treatments now. For passing on the knowledge, our champion recently retired last year. His name was Newton Bingham, if any of you knew him. He was really good at mentorship and passing on knowledge. And now I think it's kind of down to Steve and I, and we're going to be doing our best to evaluate these treatments, pass it on. And we're doing the chip seal, the thin overlay, the microsurfacing in the Anchorage and Central Region area where we can evaluate it. And then if it holds up, we'll be outreaching that to our other regions, Northern and South Coast. We're already talking to them about it a bit, and they seem pretty interested in the microsurfacing. So now we'll just be taking it on from there. Thank you, everyone.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.